artificial neural network to machine learning algorithms approach, I will try to discuss in this session. I think machine learning is the need of the day for many of the applications. So human is capable of doing this type of work from day one. So the way in which the neural networks are designed is very interesting. You just see this picture, you tell me who is she. Our brain starts working to recognize this picture. I think many of you may be having the answer with you. Many of you are still trying. The reason for this is we are not shown the complete picture. Even to recognize anybody's face, we require minimum data. For example, eye, or nose, or lips, or any forehead. If you observe in this picture, many of the data is missing. Even then, you are capable of recognizing this picture. I think some of you may be having the answer with you. I'll just for curiosity, I think you know this lady because she is an actor. So if you observe our brain is capable of absorbing even the data is missing, it is able to recognize. So this is how machine learning requirement are the programs which can think, which can act on the data or using the data able to predict the things. So that is how all machine learning algorithms are based. Out of which neural network is the best way to solve many of the problems because we humans are having that capability. The traditional programming is structured principle or object-oriented principle where we are giving more prominence to the data, prominence to the algorithm rather than the data. Whereas in machine learning algorithm, we'll always think about on the data as such. So I think with this, the most powerful problem solver in the universe, the most powerful problem solver in the universe is the human brain. I think we'll all agree with this statement. So the first we are able to do it. Then we'll make the computer to do like human and try to say that machine also solves the problem like a human. So in this regard, let us understand we are capable of doing this because of the reason, evolution mechanism. From the child to today, we have learned many things. Today you are learning something and you are forgetting something and you are using this learning philosophy for the tomorrow. So in this way, the evolution mechanism is there in the process in order to do any activity with respect to machine learning. So the building problem solver, looking at the mimicking, the brain acts as a neurocomputing. So where neuron is one of the main component in our human brain, using neurons, it able to do some computing, which is extraordinary and makes you to learn. And the computing which takes place inside the human brain, what we call it as neurocomputing. And evolution is the mechanism, I think Darwin's theory concept, evolutionary computing concept. Using these two, I'll try to give you today how these neurons, biological neuron, can be modeled in our computer system and design a neurocomputing system along with the evolutionary concept as genetic algorithm. If time permits, I'll try to cover GA. Otherwise, I'll try to cover the neural network philosophy of solving the problems of any kind, not necessarily biological concepts. Any problems today which you are able to solve it. Here, the computational intelligence or soft computing, the word we call it as now, differ from the hard computing as such. Neural network is one. Evolutionary algorithms, which are there today in many of the situations, the new evolutionary algorithms are becoming popular, such as ant algorithm, swarm intelligence. They're all coming up in order to give a boost to the computing philosophy to do just like a natural process which is going on and the fuzzy system. And for which we are going to use evolutionary programming, evolutionary strategies, genetic algorithm, genetic programming. These are all new ways of programming principles taking care of this. So there are hundreds of applications which are there in the system, solving combinatorial problems, modeling and identification, planning and control, engineering design, data mining, machine learning, biological concepts. These are all there. So what is requirement here? It is the performance. I think the performance matters. So the acceptable performance at acceptable cost on a wide range of problems is the need. So you try to catch this point. Why machine learning algorithms are required is acceptable performance at acceptable cost. That is also important on a wide range of problems. It should be so generic that should be capable of solving many of the problems. And you should have parallelism concept, robustness and the fault tolerance. Even if the data is missing, you should be able to recognize. Just like what I have shown the picture, the data is missing. Even then, you are able to recognize the actor. So in this way, the requirement for machine learning is the data is missing, the data is some of them are invalid. Even then, it tries to do a recognition process. So the superior to other techniques on complex problem is lot of data. I think in machine learning, lot of data, many free parameters, complex relationship between parameters, many local optima, and such type of things which will make you to think towards solving an interesting problem. I think in all our problem solving technique, there are two components, hard computing concept and soft computing concept. In hard computing, precise models are there. A traditional numerical modeling and search techniques which are there in the process. Whereas in approximate model, approximate reasoning, functional approximation and randomized search techniques which results in a new way of giving a solution to a problem, combining the effect of both hard and soft towards solution always give a better result for our purpose. So to this, I think the machine learning algorithm give there are many definitions are there in machine learning. Human learns from experience and computer follows the instruction. Instead, we can give experience, that is data, here we call it as, we give the experience and directly to computer to learn and prepare itself for action. Now you see the difference. Human learn from experience and computer follows the instruction. That is what we have done. We have developed the instruction to solve the problem. Instead, we can give the experience or the data directly to the computer, let it learn and prepare itself for the action. That means you should be able to predict for the next one. So in this way, the machine learning algorithms are popular. So in any machine learning algorithm, these are the steps which are required. This is generic steps which are required to almost all the techniques which are there in machine learning algorithm. Right? Defining the problem is as usual. Any problems, all problem you try to understand. All problem may not require machine learning algorithm, but today many problems require machine learning approach in order to solve. First, let us define that problem very clearly. While defining the problem, the three important parameters you have to understand: task, experience, performance. Try to catch these three important components: task, experience, performance. So, for example, you are playing a chess game. In chess game, each time when you are playing, you are getting some experience. If you are improving by performance, what is the task towards winning the game? Your task is smooth. So these three components embedded in order to improve your performance based on the experience towards reaching your task. So in this way, your problem should have these three components directly or indirectly available in the system in order to solve our problem through machine learning approach. Why does this problem need a solution? Is it really a machine learning algorithm is required? So I think playing against the computer, the chess game, we can understand the need of how computer play a game against each person. Based on the level, you can see the movement which is extraordinarily works. So that is the process of solving the problem through this. Next, the component in order to solve all these things, the experience that is nothing but collection of data. Once if you collect the data, now the huge data is available. For any problem, if you see in the internet domain, the data is available. But the data is not sufficient. You have to prepare that data. That means to say the data where it unwanted data is there, you have to remove it. For example, while talking, we'll use pausing, so unnecessary words. All these things are there which are not relevant. So we have to clean or remove all unnecessary things from your data. That is process we usually call it as cleaning, formatting, and putting all this data in a particular format. Usually, if you go for Python, we call it as CSV files, Excel files, that is comma separated values. The data is represented in some particular format, and sampling, and you will try to take data from your data set. Decomposition, if the data is too big, we try to divide into pieces so that one you can able to understand. For example, date is given, you can divide into day, month, year. And if all these data are having representations are defined, we have to scale them to a particular model. So we have to bring all of them into a 0 to 1 level or -1 to 1 level. So this process is required because it is a machine. We human beings capable of understanding, measuring the things because of our experience. So when we are developing a program, the scaling, we should be able to use strategy in order to bring the data into a particular uniform level scaling. Once the data is prepared, now we have to train the model. So for training, we split the data into two parts, the training data and testing data. Using training data, we will develop the model. Once the model is get ready for all training data, if it is tries to give the better result, then we'll go for testing. We make use of remaining data which are used for testing. Whatever the expected result is also, if it is giving by your model, then we say that it is giving a very good performance. Otherwise, once again, we'll go for training. The process of training and testing process will be repeating in the process, and finally the model is get ready. Once the model is there, any unknown data, if you start giving it, try to predict. So that is how it works. There are varieties of algorithms which are listed in the machine learning process. One is decision trees, is a very interesting tree construction process. Based on this decision tree, it is possible for us to predict the value yes or no, or even the creation of the tree itself is based on entropy measure of the data. And each node is get created and the sub branch will be created. And whenever a new data is given, it tries to trace the path, and at the leaf node will be having the yes or no answer. Another very interesting algorithm is Navy-based algorithm or Bayes theorem concept, which uses the principle of probability. And another, today what I am going to discuss with you is ANN, artificial neural network, or designing of a new neural network to solve the problem, KNN algorithm. And many such algorithms are reported in the machine learning process. So while doing, we should identify whether they fit to what type of regression model or fitting model. So whether it's linear or a kernel. With this, we'll try to understand select the best algorithm for to solve a particular problem based on data set and all this. Once the algorithm is selected, as I told, the algorithm is get trained with the data set and evolve on the test data. If the test data, for all the test data it is giving, your your model is get ready. Otherwise, you have to tune all the parameter and finally the model is get developed. So this is how a machine learning process takes place in the real domain as such. So now we will try to discuss on neural network. So what is neural network as? So from many years, these neural models are built up. For some reason, the development of the neural network was struck in 1970s to 80 range because of it can unable to solve a simple problem such as exclusive or it has been proposed by Minsky and Puppet. Finally, that model is solved with the help of hidden layer concept. So then there is a massive and as well as interesting outcomes which are come out from neural network design. Today, we are having a very good models in the neural network in order to solve many of the problems. A neural network is a massive parallel distributed processor that has a natural propensity for storing experiential knowledge and making it available for use. It resembles the brain in two respects. Knowledge is acquired by the network through a learning process. Interneuron connection strengths known as synaptic weights are used to store the knowledge. I think this is given by a well-known author Hikin in his textbook. We'll try to understand neural network concept is used in hundreds varieties of areas. I think AI is the first term we used in our computer science, which the extension of this AI concepts results in neural network, where for which we require all these areas such as mathematics, approximation theory or optimization technique, physics, dynamical system, statistical system, engineering domain, economics or the finance, philosophy, linguistic, cognitive physiology, neurobiology, and all these areas which are used in order to solve the problem. We humans have remarkable capability to perform a wide variety of physical and mental tasks without any measurement and computation. That is the capability of human capability. So we are going to see a building and try to predict or try to recognize it very interestingly. So human beings are perception of time, direction, speed, shape, possibility, likelihood, that is truth, or are the other attributes of physical and mental object. Reflecting this finite ability of the sensory organs and resolves the detail and makes anything possible. So here, these technologies are represented like this. We are having learning capability, that is what we usually call it as artificial neural network. And we are representing capability, we represent the data in a particular fashion, that is fuzzy logic or any other logical way we can represent the data. And optimizing capability. So whatever the data is there, we'll try to represent in a well-structured, very simple fashion, what we call it as evolutionary computing or genetic algorithm support that is easy. And if the boundary support, which we use, that we usually called as rough sets. So with these four components, ANN, fuzzy logic, is evolutionary computing, rough sets, we are able to do any intelligence or any problem that can be solved with a combination of this. We can able to do a justice to the problem. What is the role of fuzzy logic here? It is the algorithm for dealing with imprecision and uncertainty. So usually you'll ask, are you happy? If this question is asked, you're having a different answer to say yes or no, or partially yes, that is, I am little bit happy. Like that, we will not give the answer in the form of yes or no. There are some logical way we will try to interpret our answer and represent this data in the form of fuzzy logic. How much membership with towards the truth or false. And neural computing, the machinery for learning and curve fitting, genetic algorithm for search and optimization, The rough sets for handling uncertainty for arising from granularity of the domain of the disclosure, handling yes or no situation with respect to the support. So I will try to ask you some interesting question here. Try to see, this is the uh, ultrasound image. In the ultrasound image, some area is affected. Now you have to mark it. If you want to mark this area, is it possible to mark correctly? Even our eye, if you are going to see, there are so many areas which we cannot mark it. Can you expect the computer to mark this area and give the dimensionality for further processing? So this is how the question arises in the reality. Is segmentation is possible for this type of pictures? Even if you see the another picture here, can you easily bifurcate the black component, white component from this picture? Is it possible? These are all some interesting questions for which there is no clear-cut answer that can be possible. How can you expect the computer to do? So that is, these technologies are giving to some extent the genetic algorithm, the rough sets concept, the fuzzy logic concept, and as well as neural network concepts are giving a solution to some extent towards the natural outcome. So here we require an intelligence way of handling this, and that is usually combination of representing our common sense and thinking capability and reasoning capability. Represent this in some form of and call it as intelligence. So this results in many interesting problems that can be solved. That is how artificial intelligence, the word, which is kind in order to represent in some form of instruction as such. So the AI is ability to comprehend, to understand, and profit from experience. So this AI, intelligence on the computer concept, results in a very interesting problem that can be solved. So it's already proved AI is the part of computer science. Designing intelligent computer system is the need of the day. Now, associating these soft computing, AI has become much powerful in order to solve many of the problem. While doing all these things, we'll try to use whatever you have got the new experience, and that is the new knowledge is combined in order to give the best answer. With respect to AI or any of the approaches, what we say, you should have this thing, ability to store the knowledge, apply this knowledge to solve the problem, and for a new knowledge or a new data, you should be able to give it. So you require learning, representation, reason. So I think these three words which are kind, learning, representation, reasoning, and tries to give a best answer for which neural network, fuzzy concepts, and as we'll try to give a better answer. I think this picture will tell you what is this. I think some of you say it is the representation of a sun, or you can say the sticks are placed in such a way that when it looks like that. And if you say this picture, what is this? Is it a vase or two people are talking? This all depends on the way in which you are going to observe the picture and try to give the answer. Is there any triangle here? A triangle is placed, or these objects are placed in such a way that when there is a triangle here. You try to catch these type of pictures. We are observing this every day. So the way in which you are going to think towards the situation will try to give a better answer. So now our brain is capable of doing some such type of answers. Is it possible to simulate such a brain in computer in the form of a program that results in what is called as artificial neural system, artificial neural network? The brain has been extensively studied by the scientists, and the complexity prevents all but rudimentary understanding, whatever it is possible to understand as on today by the human being, how brain works. To some extent, the behavior of the human brain is simulated in the form of a neuron. I think this biological neuron is capable of uh, uh, doing something in our brain. That is what given in the literature, where the soma part, what is going on inside this inside the cell body or the soma part is something which is measured. Here, the signal will come from all other source. The dendrites, which carry the signal from other source, when it is put onto the soma part, the output of this neuron is placed on the axon, and this signal is passed to the next neuron. So here, if you understand this philosophy, can it is possible to model through our system is the question here. Here, there is some electrochemical reaction that takes place between the gap between the axon and the dendrite, and that is called neurotransmitters, or a synaptic gap, which usually between the two entities. So this leads to the pictorial way. If you observe all these things, there is a junctions which is between the soma connection with respect to the dendrites, and the information will be traveled through the axon part, and this results in some model representation. The inputs are nothing but dendrites through which we can. So here we can simulate some part, and finally the signal that can be taken out for many other neurons. So this, if this model is visualized, then it is possible for us to mathematically understand the process of neuron in the form of a mathematics. So this results in a biological neuron is converted into a form of a mathematical representation in order to simulate it. If many such neurons are joined together, here a massive parallelism that can be achieved in order to give you a result. So if you observe this human brain contains about 10 billion nerve cells or neurons. On average, each neuron is connected to other neurons through approximately 10,000 synapses. So 10 to the power of 14 synapses connections are possible. This is all just a calculation. So with respect to the computer, 10 to the power of 8 transistors, and just a parallel approach is there in the case of human brain. Here, serial, centralized, and we'll claim many times the parallelism in our computer system also. A small one human brain is capable of doing such thing, but we are doing our justice to problem-solving technology. Anyway, this is a comparison study. We cannot give exactly the values. To some extent, we can understand how brain works in the reality. So now we'll try to model this biological neuron in the form of a mathematical model with whatever you understood up to now. So results in a model called as artificial neural net. So it is also called as information processing system. Neuron process the information, the signals are transmitted through the connection links, and finally they are associated with a weights carrying, and these signals will get multiplied with the weights, and their results in the catching at the output signal. Applying this activation, a mathematical model of a neuron can be understood with this philosophy. I think these are all inputs, x1 to xn, n input. Each input is associated with its own initial weights, or what we call it as there is a weight on signal. Based on the weight only, the input, each input is get multiplied with a corresponding weight. Say x1 is multiplied with w1, result in x1w is passed to the soma part. And similarly, n signals, they are all getting added up and results in a summation part, and finally a threshold or a theta. If it is crosses some theta value, then it results in the output signal. So with this, we are able to get an output from at the neuron level. Here, if it is crosses some threshold, we call it as positive or +1. or -1 or 0 or 1. This is a very important component we usually called as activation function. Here, based on the type of the activation function, your output can be restricted. So with this idea, whatever we understood a biological model, to some extent, we are able to simulate in the form of a mathematical model, results in what we call it as neural network. So there are varieties of such models which are resulted. So I will not discuss much on this, all these models. I will try to discuss one model today because we have to understand from its principle of implementation to its logic. So for that reason, I will try to discuss only one function, that is on multi-layer feed forward network. We will try to understand, and to some extent a radial basis model, we will try to understand how it works. So if we are able to understand any one model, then through the information available in the textbook and other sources, we can able to understand all other models very effectively, and we can use this model for problem solving. So this is how the various computational neural network models are broadly classified into feedback model, feed forward model. In the feedback model, we are having single layer concept and multi-layer concept. And we are having in the multi-layer, more than one layer are used, we call it as multi-layer. And there are fuzzy approaches is there. So unconventional approaches are also there in the literature. We'll try to understand this model to some extent. I think you are all familiar with threshold logic. If it is threshold, we'll fix up some threshold. If it is greater than some threshold, we call it as yes. Otherwise, it is no. That is the threshold logic. So we all these inputs x1 to x1, it is are summed up, and they are get multiplied with their corresponding weights w1 to wn, and the summa part we call it as summation, and finally this sum I varying from 1 to n, xi multiplied with wi corresponding results in some value. If it is greater than this threshold, we'll try to say the neuron is fired. So xi wi, if it is greater than or equal to theta, the output is 1. Otherwise, we call it as output is 0. So this is the simple threshold logic that can be applied to simulate a single neuron as such. Using this model, we can have the problem linear way we can solve small problems. If you want complex to be problem to be solved, you require more number of neuron to give the output. So in all this logic, the activation function or the output at net output, giving fired or not fired with respect to threshold makes a how to fix up this threshold is depends on heuristic concept. So it cannot be it always need not be a constant, it changes. So when you represent with respect to theta, you can represent in graph like this. If theta is fixed at 0, your graph looks like passing through the origin. If theta is fixed at some positive value, then it is shifted. The output will be 1 if it is greater than or equal to theta. This is how a threshold function that can be represented graphically. Using this threshold neurons, it is possible to solve many interesting problems as such. So using this threshold logic, even a complex problem that can be solved, you can understand in the form of a problem solution with respect to a threshold logic. So how this neural network is designed is, we have taken the input through x1 and the initial weights, they are all get multiplied. For that value, we are applying a function on some biasing is also be applied. If you don't have a bias, sometimes the neuron will be not in the live mode. So we'll try to add a biasing to the concept in order to solve our problem. And resulting, your equation is now becomes the total weight yin is equal to summation of wi varying from 1 to n, wixi plus b, where b acts as a bias. If it is passes through the origin, then the equation will be x1 minus x2 will be 0. If you are having two variables, x1 and x2, you can represent the different equation as shown in the picture. So this results in you are having input vector, that is X. Now I am moving towards our biological problem into a mathematical problem. The layer in which you are giving the input is called as input layer. In the middle, whatever the processing, if you do more than one layer, we call it as a hidden layer, and finally the output layer. So with this, in this way, the neuron model is represented in the form of an input vector, weight vector, weighted sum, biasing, and finally, based on the activation function, the output is get ready. So updating the weights is what we usually called as learning philosophy. Whatever the weights we assumed initially may not give your output. You are expecting something, it is giving some other thing. Then we use that error and use in order to make the weight change and results in what we call it as learning philosophy. So when to this learning philosophy should be stopped? Until the error comes down to a minimum level, then we'll try to stop our process. So this is how the stopping conditions are usually imposed on the learning philosophy. So for example, how many times we will teach in the classroom? First time when you teach one problem, you'll ask for the user whether you understood. So some of you say, sir, I have not understood. Then you'll repeat the process. Repeat 2 or 3 times, and finally, we expect the student, if he is able to understand, will stop our process. So the same criteria here, the stopping condition depends on the expected outcome and the obtained output, that the result, the difference should be very minimal. So this results in neural network design as such. So the way in which these networks are connected to one another, we call it as architecture or network architecture. Setting the weights, as I told, it is called training. Initially, we are having some weights and we'll try to change it. So the activation function makes your output should be controlled. I think there are varieties of architectures are there. Simple input output collect, we call it as a single layer feed forward network. Only it travels from forward direction. Multi-layer, where we will be having hidden layer concept. You can have more than one hidden layer in order to achieve your goal. We will be understanding in the next slide how hidden layer supports in order to solve your problem. So the connection on this neuron need not be in straightforward fashion. It may be in the mesh model. So we call it as fully recurrent network, where every node is connected to all other nodes, if you observe in this figure. So the competitive network, the output is get connected to all other neurons. And Jordan in network, simple recurrent neural network, there are varieties of connections which are designed in order to model, to solve varieties of problems. I think this will be understood whenever you try to use this layer for our purpose. So now we have come to a conclusion that neuron, the while designing, you should have an input layer where you are passing your input data. We call it as features or the attributes with respect to a problem. Hidden layers, which helps you to classify your data, even if it is non-linearity is there in the outcome, and output layers are used to take the data output and expected result is not there, then we'll use it. So while training your neural model, we are having varieties of training philosophy. Supervised, we call it as the word supervised learning or supervised training, where the teacher will be there and we'll compare our results with the expected result. Because the teacher, when teacher is there, the learning is easier because somebody is there to train you, and finally you are able to learn the concept. So the process of developing such models, we call it as supervised training. Provides the network with a series of sample input, comparing the output with the expected response. If it is not there, we'll once again train. Whereas in unsupervised, nobody will be there. For example, when you learn many things without a teacher. So how we learn? That is by our own experience, we'll try to map. For example, this is a very interesting algorithm which is required for many applications. That is unsupervised training today. I think the best example I can give you is in the first day when you join to the, for example, engineering as such, in the first hour, if you imagine where you will sit, we'll sit randomly in some place because we'll not be knowing anybody in the class. If you know somebody in the classroom, knowingly or unknowingly go and sit with neighbor to him. So every day you will be get trained and your position will be start changing and you will try to settle at some place. So here, who will give the training to you? This is unsupervised way. We have trained ourselves in order to give the best possible requirement for the problem. So in this way, unsupervised training is used in many applications. Another interesting training is reinforcement that we will usually use in games as such, where right answer is not provided, but indication of whether right or wrong is provided. So using this philosophy, I think while playing the game, you'll be knowing. While learning, playing the game, you'll understand if you go on right side, some bombing is there. So we have to go on the left side. This we'll understand from experience as such. So in this way, by providing some hints, for example, profit and loss support, it is possible to learn new things. So that results in what we call it as reinforcement learning. Anywhere these training algorithms are used in order to develop the model. So the activation play an important. I think I shown one activation in the previous example, that is binary activation, bipolar activation, that is -1 to +1, identity function. So many realistic problem will not belong to this category, discrete. So we require continuous functions, that is usually in the control system, we are aware of this. So we'll go for sigmoidal function, where it is possible to take the continuous values into our consideration because our data may not be of discrete in nature. So for which I think these are the activation function which can be used at the end. This is identity function where x is equal to y, simple binary step function 0, 1 level, bipolar function. So here binary sigmoidal function, bipolar sigmoidal function, and RAM function. There are different activation function what we studied in control concept. We use here in order to make our output to be controlled with respect to our requirement. So while constructing any neural network, we should know some of the concept, that is network topology, types of connectivity, order of connection, weight range, the activation function that is used, how to initialize the weight, and how to make the weight changes at every iteration and makes the model get ready for the next level. So in this way, the neural network design depends on all these components. I will try to give you the steps, whatever is the steps in the form of design. I think this is one neuron. If you have more than capabilities of a threshold neuron, for example, this is the input provided to a neuron 1 and tries to give some output here. Like that, we are having different level. They are all given the input. And what is the outcome which will be results out? For example, with respect to such type of threshold network, we can realize an interesting function. For example, I will try to give in the form of a graph, it will be given. So the first feature and the second feature component which are there in your data. With respect to the first neuron, it is possible to classify your data into two groups, resulting a linear equation that results in x1, x2. If you have another neuron, through which if you are able to get another line, then it is possible to get classification in a different position. So like that, if you use one more neuron, if it is having the linear line at some other position, and interestingly, we can observe here, we want to group this data from all other data. It is possible to have a threshold function with neurons of capability. It is possible to classify this data and results in you can do a justification to group this data different from other. So this is the possibility of a threshold neuron in doing your classification in a better way. So this is how we can understand now a neuron capable of, each neuron is capable of giving its own output. Combining all this results in, it is possible to realize our requirement for a output layer. So this is how we can think of the concept of a. So this supervised, I say, if you want to work on supervised learning, you should know input and output. Otherwise, it is not possible to give the supervised concept. So you require training and test data with you. Training set and input and target specification, if it is given, it is possible to design a neuron. So I think you know input and outputs, you are getting some output. For the corresponding output, if the output obtained is not there, then we'll process of training starts. This results in the design of a neuron. I will try to give you the idea of this calculation and results in a model called as perceptron model, or a linear threshold unit with which the same model is put in the form of a representation. So here, this model is look like this. I think we have come to some mathematical way of representing. Your weights are changed at every iteration. Whatever the old weight is there, that is changed by delta y component. How this delta w is calculated is, you know the target and obtained output. Take the difference of this, multiplied with a corresponding input xi, and one more constant that is usually called as a learning constant. Multiply with these three terms and resulting the new delta weight, delta w is obtained. This is used in order to update the old weights. So resulting new weights are get calculated. So here, this weight used to update our data. So now how updation is done? If the output is correct, for example, you are expecting expected output and the target output is same, then will not change the weight. Otherwise, if they are not same, for example, you are expecting 1 and you are getting 0, then T is not equal to O, that is output. So then what we'll do, we'll try to change the weight. So this philosophy is used in the case of perceptron training model in order to figure out. So this I will try to give how the design with respect to a simple logic of logical AND gate. You are familiar in logical AND gate. So if 0, 0 output is 0, 1, 1 output is 1. Remaining all other case it will be 0. So now we want to design a neural model. So we are having the target 0, 0. Initial weight, say x and y are the input that you are providing. So the biasing, usually it will be set to randomly you are setting the weights to bias 0.3, 0.5, minus 0.4. You are setting initially some values. Now the training starts. We will try to provide the input. The expected output if we are getting will not change the weight. So that process of iteration will continue. How calculation starts, if you just understand, we'll represent this data in bipolar fashion. So if 0, 1, 0 is represented as minus 1, 0. When it is I1, I2, I3, so when they are get multiplied here, the corresponding, this is biasing. So biasing input are I1, I2, I3, that is your input 0, 0. You just observe this, minus 1 into 0.3 plus 0 into 0.5 plus 0 into 0.4 results in minus 0.3. The output you are expecting 0, it is giving minus 0.3. So now you can understand output, if it is not required output is there, we'll take the difference and we will try to calculate whether the weight changes that to be done based on the logic. So the learning algorithm proceeds like this. Each time presentation of the entire training data to the network and make the error calculation. Error calculation is difference between the expected output and the obtained output, and the process is repeated in order to get your algorithm. So we will use the logic of calculation, and finally we will try to derive whether it can be able to settle with respect to the requirement as well. I will try to the algorithm whatever you have discussed on this same pattern. If you are able to, you will get a clear idea. The perceptron rule example. I think delta W is clear, represent. Input pattern is supplied, the target is 0, the weight vector initialized to some 0 values, let us assume. The net output is 0, the output is 0, the delta W is also 0. Now we are initialized, instead of some value, we initialize to zeros. Next time, when the next input is provided, the expected target output is 1, and the delta W is going to change to 1, 1, 1. That is used in order to update the weight vector. The new weights will become 1, 1, 1. That is, W1 was 0, but delta W is become 1, become the new weights. So the next, when 1 is multiplied with 1, 0 into 1 plus 1 into 1, and when they are get multiplied in the same fashion, and the net output is becomes 3. Expected output is 1. So the delta values is once again going to become to 0. So in this way, we will train the model until the expected output is resolved. So one time when you are giving the input one epoch, all input and output patterns are given to your network to get trained and finally settles. So this process of doing what we call it as epoch. So in this way, we'll try to model the network, and finally, whenever the weights are obtained, we'll try to use those weights in order to classify your data to a two categories as. So in this way, the modeling is done and results in what we call it as linearly we separated our input output pattern into a two categories. That is linear separability functions. So at this time we are finding the weights W and W2 such that your red data set and blue components are separated out with a linear function. So this is the capabilities of a neuron in classifying your data into two sets. So this results in sometimes some data are misclassified. That is usually occurs in the modeling as such. So how much error is there in misclassifying the data is the performance measure. So usually if you want to take care of this one also, it is not possible in the linear model because a single line cannot possible to classify this data. You require some curve, then non-linearity starts. If there are such type of data are there, then we don't have any other option, linear capability. We have to use more than one plane in order to solve your problem, results in what we call it as hyperplane as such. So one such example is available in the net and a data set with respect to separating out the flowers, the iris data, machine learning algorithm on iris data set is a well-known algorithm in the machine learning to solve the problems. You have to categorize this data. This is how data set looks. And this is where it belongs to a particular category. So based on this, we'll try to model. So in all this modeling, we require the error. Error always helps you to make the model tune. And that error usually called as mean squared error or MSE error. So this can be nice if you are able, we'll take the input output and square it so that one negative terms will be vanished out and sum up all these things errors results in you're able to get a error, total term that is called MSE or mean squared error term. So this root mean squared error, the root of this value, put together all these values and we'll try to say until this error is get minimized to the requirement, the process of learning will be started. So this is how the desired output, obtained output, take the difference, take the square on all the patterns. If you are going to do this classification, then we'll try to take the summation of error, that is total sum squared error, TSSE is used. If we take the root of this, root means square error is used for all our error calculation. So while doing this, we'll use, for example, this is the minimum error. So we'll try to find out this minima using gradient descent technique until the error is get minimized to a lowest level, we'll try to find out. So sometimes while doing this, your initialization matters. So a local minima, you can held up with a local minima. So in order to avoid this, we'll reinitialize at some other position and we'll do the calculation. compare the results, and we'll try to find out a global minima for with respect to your function. So this is how a gradient descent learning algorithm, usually the goal here is to find out the overall error at each time of the weight is changed. Total error is calculated until this dabba E by dabba Wij, that is differentiation with respect to weight function is used, is a negative curve because we are finding a error at a least value, resulting at each time it is reducing, and finally it will be settled at the lowest error value. And we use while doing this calculation, there is a small change in the work, that is you call it as a delta rule. So delta changes in your concept resulting a delta rule. So this is the delta component or a delta rule. Change in the weight is the difference between the target output and obtained output with the corresponding input and a learning constant as such. So this learning constant is usually measured between 0 to 1. If you make 0, there is no meaning at all, you will not at all learn. If you make 1, it is a sudden change in the output occurs. So for that reason, we'll try to fix up the learning value to some value, say 0.5, and start changing this C value along with the weight change, and so that it is possible to learning constant is also as a component which will play a role in changing the weights. So in this way, a delta rule concept is used in order to make your models is get ready. So here there are two types of updation as done. Whether you update your weights in one batch or at each time whenever the input output is given. So if you until all batch of one group of data is used for training, if you don't change, then batch processing update is done. Or otherwise, at each time if you want to do, then the stochastic approach is used. So in order to understand this principle, so I will give you a simple equation. Now, if you observe, I want to classify this data into two parts. Now observe this data. The data here -3, -2, -1, 0, 1, 2, 3. Now you have to observe this. Is it possible to use a single linear line that categorizes this data? For example, these green 2, 3 and -3, -2 belongs to one category, and this -1 to 1 belongs to one category. If you use our traditional approach or the perceptron, whatever you learn, one feature or F1 is not possible to separate. So something to be done for this feature. So let us a simple calculation that will apply. Make F2, create an F2 which is equal to F1 square. Then automatically your data looks differently. Now you observe the F2 looks. No, a single linear line that can be with a threshold line that can be placed so that one green data will be separated out from red. So this is some heuristic way we have to take care of data set in order to solve our problem in the reality. So this type of technologies are used along with our modeling in order to give the output. Results in this single layer concept is passed to a multi-layer concept, which solves very interestingly the realistic problems which are there. Maybe optical character recognition. Now I think many models are there. Car design, I think without driverless cars are coming out. Where how these machines are designed, it tries to signals are obtained from various sources, input signal, and a model is capable of catching and giving a signal to the output control. So this results in a more than one layer concept, results in what we call it as multi-layer. So here a single input output layer, in between that there is a hidden layer will be come into picture. So this hidden layer results in a new concept of today, what we call it as deep learning concept. Deep learning where will not give input at all. So it has to learn by itself. Even the input it has to be taken. That is how the concept is figured out in the case of deep learning. Anyway, in understanding this, let us understand this with mathematically a model of this kind that is called as adaptive linear model, or we call it as ADA-line model. So here in the ADA-line model, as usual, your input, obtained output, there is an error, output error generator, that is error, difference between the target and the corresponding input, and the way it changes, that process will be done and results in your control yourself with respect to the output requirement. So this model is used, Ada learning rule, the same, whatever you have used, that model is used. So in this initialization, training, thinking. So here training is done and finally you are able to give a justice to until the error is reduced to smaller point, error function or error value. Until that error is reached, we'll be repeating our training process and finally we'll try to recognize. So for all this thing, error calculation play an important role. So here W1, W2, your input output pattern. With respect to weight, we are going to differentiate your weight function. Initial value of W1, W2 are somewhere. In the next iteration, it is tries to change your delta values and settles at some position, the new value, W1, delta W1 by which. So it is moved, your error weights are moved to some other position. Up to which value you want to move this W1 or weights changes is the matter. Until a local minima that is reached with respect to error curve is matter. So if that error curve is taken vertically, it looks like a parabola. If it is taken horizontally, it looks like an ellipse. The same error curve, whatever you have understood, if you take the error surface in a space with a horizontal axis, it looks like a parabola. So if you initialize at some position, say at some other position, you start differentiating with respect to weight until you reach the local minima here. We'll try to iterate. If start rising, then we'll stop and we say we are learned. So this is how the logic of learning philosophy is used here in order to calculate our process. That is the error with respect to weight change. So at each time, if you say wait, each time the error curve will be start shrinking and finally set on some position. So here while doing, we can use batch processing or with respect to stochastic process, or in a group we can do, or each time we can change the value. That is depends upon your requirement. It is possible for us to change the weight on the processor side. So this results in a multi-layer perceptron concept is used in order to many such ADA lines are joined together, results in medallion. So what we call it as multi-layer adaptive neural network. If you understand here, a hidden layer has started coming. So this is the starting stage, and using this concept only, a back propagation neural network is designed, a very popular network in the literature of neural network. They call it as BPN. I think you maybe heard this word, the BPN network. A back propagation implement a gradient descent search. That is what we have understood, the calculation of the weight until the weights is reduced to a minima through a space possible network weights, and iterate until the error E is comes down to a very minimum level and results in a network that is called as back propagation network. I think this model is a very popular model, and even today, whenever you start your neural network for any application, we'll use this model in order to classify. In this way, it looks like this. That is, all your input I1 to IN, I0 is the biasing with respect to every hidden layer, and output. Need not be output, need not be one. There are multiple outputs are possible. Depends on your application. Some of the output, yes or no, we will go for a single output. For example, number recognition, let us assume. You want to recognize OCR for number recognition. There will be 10 outputs. All of them will be giving the output, but whichever it is giving the most highest output will be considered as the output for the present input as such. So remaining all other outputs will be neglected. So in this way, we can use multi-layer feed-forward network in order to get. How this hidden layer network, for example, up to now, we have taken only one layer, calculation of the error is there. How the weight changes occurs in between input layer and the hidden layer, and the hidden layer to output layer. So this logic should be understood with a. So for all these things, our simple linear function will not work. So we have to use some activation function. It should be differentiable. At every moment, it should have a capabilities of differentiable uh, and results in gradient descent technique that can be applied in order to find out the minimum error, a back propagation, a sigmoidal activation function with binary or bipolar activation function that is used in order, because the function, the sigmoidal function 1 over 1 plus e to the power of minus x, when it is possible to get the differentiation of dy by dx of this function results in 2 divided by 1 over 1 plus e to the power of minus x minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x plus minus e to the power of minus x.
Sir, video got stuck.
Sir, it is not audible. Sir, it is not audible. Sir.
I think there's some network issue. I think
Okay, sir.
those who are want to develop a neural model for any of your application, I think this is the first basic concept. If you are able to understand, you can easily solve the problem. So here, this is first hidden layer, and this is the second hidden layer, and this is the output. I am taking only one output, y. Uh, when the inputs x1 and x2 is given to f1 function, they are multiplied with w1, w2. The results in f1 corresponding function is multiplied with wx11, wx21 with corresponding input x2, results in output here y1. Similarly, the function at f2 we call it as y2. Y2 is the activation function f2 is used. Usually here the sigmoidal activation function is used because of the support of differentiable function instead of a linear function. Similarly, the y3 output, here now you know how to calculate y1, y2, y3 at every output layer. Now this is used to calculate the output at y4. Output at f4. So here the function f4 is get multiplied with the corresponding initialized values, and y4 is obtained in the same fashion whatever you have used the logic for a single neuron. So in this way, f5, and finally we are able to get the output at y. It is a function f6 multiplied with a corresponding output. So one input is transmitted from input to output. Now you got the output y. So now you are having obtained output. So you know the expected output. You will take the difference of these two, that is delta. So the difference between these two is used as an error term. I hope this pictorial representation helps you to understand. Go back once again to update the weights at every level. How to update the weights? Delta rule. The same delta rule concept is used here to change the weight. So we'll go back and change the weight W46 multiplied with a corresponding delta term, that whatever you have calculated delta term, and a new delta 4 is obtained at this stage and the weights are updated. So similarly, W56 delta 5 and delta 4 delta 5, which indirectly helps in updating the weights of the previous nodes and giving delta 1 W14 delta 4 W15 delta 5, because there are the component helps you to get the weight change in the component with respect to W14 and W15 support. And finally, W1X1 is obtained here in order to change the old value W1, whatever it was there, is changed with a new weight change. Corresponding input is get multiplied to
I request the audience kindly wait. There is some technical problem here.
hello. Because of some network problem, I think. So anyway, here the concept of back propagation is used in order to update the previous weight. This process of iteration is continued until the error or the expected output is resolved. So this is the logic which is used, what we called as the philosophy called as learning. I think you understood how whatever the weights are changed here, the same concept is used to change the weights of hidden layer to output layers W46. The obtained difference error multiplied with the corresponding Y4 with learning constant n and the old weight is used to update the new weights. in this way, the weights are changed at every iteration and in order to get the result. So while doing, we are going to use batch mode. That means to say over the entire data, we'll try to take the error term. Or we can use at incremental mode whenever a new date changes occurs, the change in the weight. We can use any of these strategies based on your requirement and the obtained output in order to change the. So this is the logic of what we call it as BPN or back propagation neural network in order to give the best possible output with respect to a sigmoidal function. This is one diagram which mimics the complete logic of a function of a BPN network with initial output, activation function. We'll try to use an activation function, differentiable activation function, that is 1 over 1 plus e to the power of minus x, a well-known sigmoidal function, because when you differentiate, we'll get in the same value, that is the sigmoidal function value, 1 minus the same function results in dy by dx. So this is used to update the weights at every iteration. So this concept is used in order to get your result. Now we can understand the algorithm better. So instead of initialize each wi to a small random values, that is initialization of the weight, until the termination condition is met, that is the stopping condition, until the error is going to be done. Do following things iteratively. Apply your input-output pattern x1 to xn to the target output. At every instance, we'll try to calculate the output at every node, 1 minus of corresponding activation, and result in obtained output might result in output. We'll take the hidden layer calculation, update at every node, that is wij, and the process is repeated as shown in the previous picture, and this process of iteration continues until the error comes to. So this results in a very interesting problems through which that can be solved. Many problems are in the literature, we can see they are solved using this back propagation with a gradient descent for the entire network for the weight vector. Easily generalized to an arbitrary directed graph. These are all some of the advantages through which we can increase the momentum by adding some more additional quantities, because this one of the major drawback of neural network is learning is becomes slow, but once it is get learned, it is possible for us to recognize easily, but learning takes more time because of today's machine capability. Learning is also become very fast. So like that, we can find a neural network. So whatever the pictorial is shown, in order to understand, there is one worked example just to understand how weights are there. You understand here x1 is 1, x2 is 0. That is the input. Input weights are provided. This is the hidden unit, u3, u4, and the final output is v. The target output you are expecting 1. Initializing some values, 3, 6, 4, 5, 2, 4, and this is the biasing, minus 6, 1, minus 9 point, some values which is supplied to the network. So this is the initialization. How these weights are changed using whatever you have learned up to now is training this algorithm on the input pattern 1, 0. The target output is 1. So just understand how calculation proceeds. I think the initialization is clear. Your expected output is also clear. 1, 0, you are expecting output 1 logical OR gate requirement. Now the training starts. At this stage, we will try to calculate the output, that is multiplication of 1 into 1, that is the biasing value 1 into 1, plus 3 into 1, 4 into 0, resulting 4. So y3, function of 4, that is your function is used, it is activation function is sigmoidal function, 1 over 1 plus e to the power of minus x, here x is replaced by 4, resulting 0.982. I think you got the value here. Just whatever in previous slides, which just gives you eye view. Now I am giving you the problem through which you have solved. So similarly, if you are going to calculate at U4, same logic, the weights are changed here, resulting here 0.5, and this is used at the output layer 0.5. So that is 0.51 is the network output. What is the expected output? The target output is 1. but you are getting 0.5. So you'll take the difference 1 minus 0.5, resulting 0.49 is the error that is obtained at here. This is used to update all the remaining code. We will back propagate it. So when you back propagate, delta phi will calculate. Delta phi is 1 minus y phi, y target minus y phi. You already know 0.51, 1 minus 0.51 into corresponding difference you already calculated, it is 0.49. When it is get multiplied, we will be getting 0.1225. So at this delta phi, similarly calculate delta 4. So delta 4. Come back and you calculate delta 3 in the y3. y3 multiplied 0.0043. And once again you come back, just on delta 5, delta 3. And similarly, when it is getting, when you are taking learning constant, say 0.1, using delta wij, that is learning constant, is get multiplied with the corresponding delta and input. 0.1 into 0.0043 into 1 resulting 0.0004. So this is how weights on 0.3 is calculated. This is used to update your old weight. Old weight is 1. It is added with this term 1.004. So resulting, likewise, we'll try to update all the weights in the network. So this results in the new weight change in updated weights in all the network. This process of iteration continues until your error term is get reduced to a maximum. So if you observe the calculation, after the first iteration, output at y3 will be function 0.981. Similarly, y4 it is 0.5, y5 0.52. So the target output is 1.5, 0.476. Previously it was 0.49, now it is 0.476. There is a difference in error, that is 0.0014, through which you are improved. So this is the logic is used in order to understand our BPM network. I just shown this concept from which are taken from neural network learning and expert system by Stephen. He given this slides in order to understand. So we understood a concept called training. This was a single iteration of back propagation through which we are able, but it is very, very slow. But nowadays, because of the power of the machines and some other means, it is possible to develop an MLP algorithm with a very fast parallel computation which are possible. So here in all these things, we should understand one interesting thing is, how many examples should be given? If we give more amount of data, it is possible for the real problem that can be solved effectively. And disjoint training and testing data set is required in order to minimize the errors and make your any new data should be get checked. So using this logic, there are hundreds of problems are solved, and some of them are in image processing, in medical diagnosis. I think the fault diagnosis of any of the diseases. So the input features are there, and you are expecting something. The obtained output is, until it is reached, the BPN tries to give for a very good output for many of the applications as such. They used in many reality. The interesting thing is a small change with respect to BPN results in a radial basis function. In all this input, we are using only one input, but input is a group of input will be there. In that situation, what we'll do is we'll take the mean and standard deviation support of input vector in order to apply on the input data. It results in a new network that is called RBF. Is a classification and functional approximation neural network developed by Powell. It uses most common non-linearities for a sigmoidal. A Gaussian function is used. A sigmoidal and Gaussian function, if you observe, the Gauss function which help you to take the mean value with respect to your support and a standard deviation from the mean, which results in a group of data that can be applied in order to make your learning philosophy works for some varieties of application. So Gaussian function e to the power of minus y square, that you are familiar, the same function is used here in order to do. So the same concept is same, whereas this results in a new network with input output pattern change into a Gaussian function level. So many such applications are there in the literature. OCR, optical character recognition, is you one such example, which is already proved to be a very interesting application. Just I am giving a summary of whatever you learned today. The perceptron model, ADA-line model, that is adaptive linear model, MEDA-line model, back propagation network, radial basis function. These are all some of the functions which you understood now. There is many new inventions which are going on in the neural network. New models are coming up to solve varieties of application for the today's environment. So these are the some applications which are coming up are already solved in the case. So we require some genetic algorithm that can be able to solve an interesting problem to some extent. A genetic algorithm. Just I will give you a hint. I will not go very depth. Already the time is coming up 4:30. I planned for only neural network. I think some of you may think how genetic algorithm works. Just for curiosity, genetic algorithm is based on the philosophy of Darwin's theory support, in which there is selection, crossover, mutation. These three concepts are used in order to fine-tune our application. Here, GA concepts are applied even to the neural network in order to get a best possible output, because it is optimized outputs are possible. So I think I will not go very depth. The time is already coming up. Just for curiosity, just I will give you one slide which will help you. Many of you are aware of how chromosome look, genes which are responsible for. So here algorithm looks like this. Initial population, evaluate the population. The three steps are selecting the best parent, recombination, and mutation. That is crossover and mutation. Results in a new population that is used for the criteria. So this logic is used in order to optimize the results, obtained result to a greatest tuning. There are varieties of parallelism in genetic algorithms are there, but is already time is up. For that reason, I will try to wind up the components of this GA with a one picture which works. One is coding, how to represent the data. Here also string are used representation. Fitness function, using that representation, what is the functional value you got it, and how to make it to improve by using crossover and mutation. So these three principles. For example, this is the best parent. There is you represented your string, a gene in the form of a represent. So the crossover is used in order to get a new offspring. So the obtained value for which we will calculate the functional value. And finally, we will try to mimic. And some of the terms we will try to move. So the crossover can be done with a single crossover or multiple crossover. Using these new parents, we will be able to get. So you just observe here. From this, the first part, FGH from the parent 2 is taken. BCD is taken from the parent 1. And A is once again taken from the parent 1. New offspring is get generated. So using this, the functional value changes. So this Darwin's theory is used in order to get the procedure part. This is the total process. That is the population, evaluation, fitness value, reproduction, crossover, mutation. This process is repeated until you are getting your result to an optimal level. So after the mutation, one or two strings that will be flipped in order to get your output value. So there are some techniques are there. Since the time is up, I will try to wind up the process of calculation of this same thing which is available. Those who are interested, add this genetic algorithm component to your neural network. Make a strategy, neurogenetic algorithm concept for many of the application, which results in a better solution for a. So with this, I will try to wind up the session. So many interesting things are there in the literature, and try to Thank you. Everybody has patiently listened the concept of neural network. Whenever you want to do any new things, deep, honest, sincere, commit, and try to solve your problem, you are able to get a solution to your problem. So with this, I will try to wind up the session.
Thank you, sir. Thank you for presenting an insight into the artificial neural network and genetic algorithm. So, more participant, I request you, we will be sharing the PPT recorded presentation at the end of the FT. Lot of appreciation is coming. Thank you once again, sir.
Just once again, all of you for patience, listen. But even though mathematical part is there, I don't want to give you highlight just for it is possible. How it is possible is my idea behind it is not there. For that reason, I just show the with a specific. I hope you will learn this and use for your career. So good luck.
Okay. Okay, participant, we'll meet tomorrow. Just we'll wind up the session. Thank you once again, sir.
Thank you.
Madam, this is Karnaka Reddy. From my side, small request, madam. Madam, when